Hello, this is Mark from I Am Organic Gardening, located in Zone 6B in the state of New Jersey. And welcome to Part 5, How to Grow Nutrient-Dense Fruits and Vegetables in Your Garden. And today I'm going to explain how we extract those minerals out of our sand, silt, and clay through the biology of our soil to feed our crop all the nutrients that it needs to provide us nutrient-dense vegetables. I just took a step outside in front of my large kitchen garden on this beautiful day, and I'd like to explain to you the method that I'm explaining, or the process that I'm explaining, is what I choose to do on my farm and in my large kitchen garden. I'm not trying to talk you out of your method, because whatever you're doing gardening wise, or style, or method, or technique you're doing is fantastic because you are gardening. I choose to do this because I have a large amount of acreage. I have over 22 acres of land. Now, for me to induce another product into that soil is going to be costly. So I'm going to have to come up with something that I can use that is very profit sharing and also less costly for me to use in the future. So that's why I'm trying to inform you of this type of technique and method. Because when it comes down to it, I don't have to spend anything except seeds to put a living root in the back in the ground, which I'll explain later in this video and also in the other videos to come. And I will show you in this entire spring season that will be coming shortly, which I can't wait to get out there and plant again and grow things and share with you once again too. And the excitement that you share with me about your garden is just ultimately fantastic to hear from all those people that are out there reaching out to me. So this method that I'm using, how to turn dirt back into soil, living soil that can provide nutrients to my plant free of charge, again, is just costing me the cost of the seed to grow a cover crop to keep that ground living with microbes in the soil. Now, what you see in the background here, and I'll get a better shot here for you, is I use a lot of leaves on my property, and that's in different places from year to year. And I don't want to distract from the main focus I'm trying to do in this video of how to rebuild soil. Because with all these leaves you see on my property is, yes, I'm using that as a cover sometimes or growing directly in them. The main reason I'm doing that is because I get paid by the township a very good price to, instead of them dumping them in a landfill, I take them at a cheaper price than they pay. I'm saving the township money. I'm getting clean, free leaves from the park system, and also they're paying me for it. So I'm making a profit to continue farming on my land. That's the reason I bring them in such quantity, like you see in the background. These are just piles of leaves. That's just about maybe 3 truckloads of leaves that they brought in. And I have them scattered out, and also you'll see in so many videos that I have a lot of leaves in the background. That's because I am making a profit on those leaves, and that's a business for me, just like a business of growing vegetables. If I didn't have them, I can still use the same method I'm using that I'm explaining to you to grow soil and get those nutrients to my plants, that I can sell a really good nutrient-dense, let's say tomato, eggplant, cucumbers, lettuce, you name it, to my customers. So here in front of us now, we have about an acre of land. It's about 210 feet long by 210 feet wide. Now what's nice about this is that I want to show you how powerful and how much the soil needs to eat things to deliver those nutrients from our sand, silt, and clay to our plant. So like I mentioned before, we have an acre in front of us. Now, if you put 2 elephants on this acre of land in front of us, from here to the barn, and they just basically grazed around or eat out of a trough, whatever it is, 2 full-grown African elephants, this land eats the same amount of material that those 2 full-grown elephants would do in a day, minus my dog out there. Now here's a good example of how the soil regenerates itself and keeps itself alive and pulls nutrients from the soil, our sand, silt, and clay, and gives it to our plants to produce nutrient-dense vegetables. In front of us now we have my raspberry field, or raspberry canes, And I originally started with 100 plants. There was 50 in each row, and they have grown immensely over the last 4 years. Now I make around a little over $1,000 a year off them, depending on how many raspberries I can pick. And I don't even get close to even picking off of like the second row. It's pretty much just the first row. Now, what's nice about this is that it's a good living proof, your trees and else too, that it can pull nutrients from the soil constantly through its entire life. And I haven't fertilized or done anything to them for disease or pest control, irrigation, you name it. They have just grown on their own. Now, I know what's coming through your head, and it's the same thing that I thought also too. Well, Mark, that's not a tomato plant. You know, that we pull more tomatoes off. We can pull 50 or 100 pounds off of one plant. We're pulling nutrients from the soil. And I referred back to part 4, where you don't run out of minerals or nutrients in your soil because it's locked up in the sand, silt, and clay. But it's a good, perfect example to start with to show you that those raspberry canes, which I'm picking off fruit from, that I never replace or add compost to the ground or manure or anything. I just let it grow, and that can produce something year after year for me that I can make money on. And to go into just a little bit more description, with these 2 rows of raspberries that you see on both sides now, that it's working so well because it's a living root in the ground. I'm not tilling the soil. I'm doing absolutely nothing to it. Every year, those leaves come out, collect sunlight, feed the soil, and give so much to that soil, first of all, to recharge it. And that's the purpose of the plant. The purpose of the plant is not to give us vegetables. That is just a secondary thing to reproduce itself, to give seeds. We enjoy those vegetables and we need them, but the main goal of the plant, and this is what I had to wrap my head around, the main goal of these plants is actually to feed the soil. They're giving 51% back to that soil. They're putting carbon back out of the atmosphere, cleaning our air, reducing our temperature of our atmosphere all the time by putting that carbon back into the soil, and also exchanging this is, listen, I'm going to give you carbon, and I'm also going to feed all the microbes in the soil all the things you want. I'm going to give you the best quality food. And that's what nature does, is I'm going to give you the best quality food, that I'm going to take carbon out of the atmosphere, and it says, again, feed that soil, but also feed the microbes. And those microbes say, hey, what can I do for you? And what they do is that they bring the nutrients to the plant that it requests, that it needs to stay alive. So that's really the function of a plant in our planet, or on our planet, is to actually feed the soil, because it's a living part of the thing. It's an extension of it. And that's the main purpose. We just get the benefits that we see, but we have to look beyond those benefits and go back into the soil and say, you know, those plants, they're really doing an amazing job by keeping our soil alive, and that's the purpose of that plant. Came up with a very catchy slogan that you can relate to other customers and you can keep in the back of your mind, and I hope it will give you the incentive to always think about it. So how do we take dirt and revive it into soil? We perform CPR on it. The C stands for a little bit of compost to get those microbes back in our soil if they're not there. Cover also starts with C, and keep that soil covered as much as possible. 2, the letter P. The P stands for plant. We have to have a plant and a living root in the ground to feed those microbes, because the compost on top and the soil litter on top, like leaves or hay or straw or wood chips, that's only going to provide a little bit. We need to feed the soil. What it really, really wants is to take that living root or that plant to push down that carbon out of our atmosphere, store in the soil, and also feed our soil food web. And the R is to regenerate. Just watch back and let nature work its own process of doing it on its own. And you know what? All of this is free of charge. You don't have to do anything except maybe spend some money on seeds or a perennial root in your garden, and just keep that soil alive, taking carbon out of the atmosphere. And I'd also like to say too, in the beginning, is that you can never, ever, ever fail at gardening. Because if you have that living plant in the ground, you have accomplished the biggest thing on this planet. You have taken carbon out of the atmosphere and pushed it back into that real soil of sand, silt, and clay. That is a huge thing. You're cleaning the air, and you should always reward yourself. Even if you don't get that tomato off that plant or anything else too, for as long as that tomato plant was living in your garden, you have taken energy out of it from the sun and pushed carbon back in the soil, fed the soil food web. Right there, you have done 51%, more than half of gardening. And yes, it would be a great benefit to make a BLT at the end of the garden season. I took a step back inside, and I have this little bit of a demonstration set up of how the soil biology works. The proper name is really called the soil food web, and you can look at and research online and further educate yourself on how well it works. But I'm going to give you a general overhaul description of how it all works in this demonstration using a couple of props. Now, we all start, as we know, with our sunlight, which is necessary to create photosynthesis in any of our green plants on this planet, including weeds. Now, like I mentioned before in the other parts, that's going to take that sunlight and carbon dioxide out of our atmosphere and make root exudates. Now it's going to take that and store carbon in our soil, but is also going to create a delicious meal for our soil food web and the biology of it. Now what it does that, it makes sugars and carbohydrates, and I'm just going to keep it simple. So now, the best thing is, and in our sand, silt, and clay here, we always start, no matter where you are on this planet, we always have enough bacteria. That's the first thing that's in our soil. And there's usually about 1 million of them, at least in a tablespoon of soil. Now that is probably the highest amount of concentration that you don't want in your soil. You just don't want bacteria. You also want to create a fungi presence in the soil. You actually want a 1-to-1 ratio of that in your soil. Now I know this might seem undoable, but it's done all the time. Don't worry about this. It just takes time for your soil to do this by you maybe helping it a little bit, or it will do it on its own once you have a living root in the ground. It will actually regenerate it, just like those raspberry plants. And I will make a separate video of that soil around the raspberry plants, where basically those raspberry plants capture the sunlight and then has changed the soil from a very dark clayish soil into a rich organic matter soil, and is doing this and feeding those raspberry plants all the time. And I've done nothing except put those raspberry canes in the ground, and it has taken years to do this. Now I planted those 4 years ago, and I'm sure it did it a lot sooner, but the key is a living root in the ground. It's not always it's a quick fix if you want to put compost on the soil. It's a quick fix if you want to put just leaf mold on top of the soil. But the living root is necessary in the ground to get things working the proper way, like it has done in nature all the time, and again, free of charge. So the first thing I'm going to demonstrate, so now we have a little bit of a prop. We're going to add some bacteria in the soil. That's going to be all these little round pieces here of multiple colors. Now we're also going to introduce, and that's what our soil starts out with, a lot of bacteria. Now we want to increase the fungi in our soil, and I'll explain how that's done. But this is the fungi that comes along too now. Now these are different pieces here, and you can see that they're oblong, and they mix in and they pretty much start eating the sand, silt, and clay, and also the organic matter to stay alive. And it has to have enough moisture inside that ground to keep that all alive. They have to have oxygen, and they have to have moisture. So it doesn't have to be wet, but the soil has to remain moist. And that's what keeps everything going. Just as a quick idea of what actually is there. Now, there's over 75,000, they discovered there's over 75,000 different types of bacteria in the soil, and 25,000 species of fungi. That is amazing. So there's, again, 75,000 different types of species of bacteria and 25,000 species of fungi. Now this alone, and this is what I had to grasp my mind around also too. This alone here, when they're eating the organic matter and the sand, silt, and clay, and giving those nutrients, they cannot give those nutrients to the plant. They are not plant available when they're eating all that material. Something else has to come along. So let's go back to the soil food web, and that's what this is demonstrating right here up on top. Now we see that we have to have other different types of things that eat them. So what eats our bacteria and fungi is our protozoa, which is all different types, and our nematodes. Now, when they eat them, they take energy away from the bacteria and the fungi, feed themselves the available nutrients that they need to stay alive, and then when they produce castings or when they poop things out also too, then and only then it is a plant available nutrients. So let's add in our protozoa. We have all different types. So that will be these. These are our protozoas. And then we have our nematodes, which will be these guys here. And they will come in. And now when they digest the bacteria and fungi in their bodies and excrete them out, all these, again, like I said, those are the plant available nutrients. This is going on free of charge in your soil, in real life soil, all the time, 24 hours a day. Now, what's nice about this is that sunlight is, again, feeding all this going on. That's, again, taking carbon dioxide out of the atmosphere, pushing carbon back into the soil, and also taking root exudates, which is sugar and carbohydrates, and feeding all this so everything stays alive. Plus your moisture in there in the ground and your oxygen that you need. Now this beautiful system of nature and what we call the soil food web has been around since day one. This is how the planet has created its living condition for us to just sit back and enjoy. And again, it's doing it all free of charge. We don't have to intervene at all. The less we do, the better it is. So now I want to give you a good idea of what bacteria, fungi, protozoa, and nematodes look like in our soil. Now I took a soil sample and looked underneath the microscope at 400 magnification, and this is what they look like in real life here. Now just enlarge it a little bit. Now I'm going to point out with a pencil here in a little bit. As soon as I grab a pencil, I'm going to point out the bacteria. These are those small little dots that are swimming around. Those are the smallest parts here. Now they're all in the soil in this liquid solution, and they need water to swim around. Not a lot of water, they just need a little bit of moisture. Now here is our first type of protozoa. Now that will eat the bacteria and fungi in the soil and release, after it's done eating it, it will take the nutrients it needs to stay alive. That's inside here, which I'll point to. Inside there is the bacteria and fungi that is eaten already, is going to extract the nutrients it needs to stay alive, and then it will excrete them or poop them out, and then those nutrients that came out from that protozoa will feed our plant. Those are plant available nutrients. Only until that protozoa eats those bacteria and fungi that's in our soil and retains the nutrients it needs, then poops it out, then it becomes plant available nutrient. Now here we have strands of fungi in our soil right now, and I'm pointing out with a pencil here. Now you can see that they make these oblong strands that grow in our soil, and there's a bacteria swimming around right in the middle there. Now those strands are linked together at little junctions every so often to increase strength. But those strands will transfer water and nutrients from one area to another. And here's a very good close-up of it. Now here's another example of a protozoa. And here is the mouth to it. And then you can see inside the body here where the little white hand is that it has captured some bacteria and fungi that it's eating for itself, and then will make, as it poops it out, some plant available nutrients. So here we have our last example. This is called a nematode. Now down below right here is the mouth, and that's where it sucks in the bacteria and fungi that's in the soil, and then you can see it's all inside already too, and then we'll slowly digest it, removing the nutrients it needs to stay alive, and then whatever is left over it excretes outwards, and that's your fertilizer. That's your plant available nutrients, 100% organic and does a fantastic job. And again, we'll just start the video here, and then you can see that it moves around nicely in the soil. But again, it needs that adequate moisture in the soil to move it around. It's like a miniature microscopic worm. So now we have a good, simple understanding how everything works. Sunlight comes in, plant captures it, uses it for energy, then takes carbon dioxide out of the atmosphere, then we'll push carbon back in our soil through root exudates and exude them into our soil, but also the plant will make sugars, carbohydrates, and proteins, and that will feed our beginning of our soil food web, which is the bacteria and fungi in the soil, and then the protozoa and nematodes will eat those fungi and bacteria, and whatever they don't need, they exude outwards, and basically that's your plant available nutrients. It is all your micro and macronutrients that you need for your plant. So now it becomes more interesting in seeing how things are going. So anytime you introduce anything to your soil, any organic material that you have, this excludes any chemical fertilizers. Anytime you use organic material and you mix it in your soil or lay it on top of your soil, like eggshells, leaves, wood chips, straw, and compost, all this will be attacked and be eaten by the bacteria and fungi. And then again, the protozoa and the nematodes will go after it. So all this will be digested by the soil food web and introduced to your plants. And that's the way you know that the soil food web exists and is working in your garden. It will break it down and digest it. This here, the bacteria and fungi, is the main purpose of this breaking down. And this is what you can see throughout nature, anywhere you walk on this planet, that it's breaking down those type of things that we lay on top of soil, or nature leaves as litter on top of the soil. And what happens next after this, I always mention that you have to increase the fungi in the soil. It's not the fungi that you see just basically in the soil, those little white strands. And you'll never see, and that's in the next part, you'll never see mycorrhizal fungi in your soil, because you have to look underneath a microscope at 400 magnifications to identify it and actually see it working. So this fungi here, again, is in the soil. But also the definition of fungi is anything that you have around the soil area, anything that's on top here. Now, if this is the bacteria that we have in our soil, all this from here over, meaning your fungi, your nematodes, your arthropods, your larger arthropods, your birds, your animals, that's considered also by definition through the soil as fungi components. Anytime they eat something else, like a spider eats an arthropod or a bug, when that spider excretes something, that spider is also adding plant available nutrients to your soil. Biggest thing, and everybody talks about them and love them for sure, is worms. Now, worms do an amazing job, but again, they're eating that organic matter, they're digesting it, and there's bacteria and fungi on top of that organic matter they're eating, and they're turning that into plant available nutrients. It's not that they're just eating a leaf. On this leaf here is lots of bacteria and also fungi breaking it down. So when that worm eats it and goes through its digestive system, it is also producing those castings, and those castings are plant available because it has digested something else, the organic matter, the bacteria and fungi that's on this leaf. And all this organic matter, the eggshell, is also considered and also being eaten by lots of bacteria and fungi as soon as it touches the ground. I hope I explained and gave you a very good general definition of what's going on in the soil. If you have any questions, please ask them, because the way gardening works for me is to understand the biology or the microorganisms of the soil. And when you have that good understanding and confidence of it, you'll know how to react to your plants and see what's going on. Again, with all this going on, they need moisture and also air for them to function. And that's why a lot of things go, let's say, sour in the garden later on in the season, is because the soils are drying out, and that's the main reason that your diseases are setting in, your pests are coming back, and production slows down, is because you don't have adequate moisture in the soil. I want to thank you very much for watching today's video, and if you have any questions whatsoever, leave them in the comments below. And again, thank you so very much for watching all these videos all the time. I enjoy sharing my knowledge and with you. And again, I've learned this, and if I can learn this, and so can you. Gardening is very easy to understand when it comes to soil biology. Do not fear dirt or soil. It is the key process in creating nutrient-dense fruits and vegetables. And I will show you how the last step, which is in the next part, the mycorrhizal fungi in the soil, how that is so evident and so necessary. And that, in combination with all this here, will create your nutrient-dense vegetables free of charge, extracting all those nutrients and minerals out of the soil that it constantly needs all the time. So until then, enjoy gardening. It's beginning soon, and I'm sure a lot of you have already started some plants indoors. And if you can, just share with me all your tips that you have, and keep enjoying everything. And if you get a chance, please like and share my video. It helps out my channel immensely. And until then, enjoy, and I'll see you shortly. Thanks.